Now we are in chapter 2.1 and we're going to be looking at the addition property of equality. Objective 1 is to identify linear equations in one variable. So what is a linear equation? Well, it's an equation written in the form ax plus b equals c, where a, b, and c are real numbers, and real numbers just mean they are any number. So any number you can think of is a real number, and a is not equal to 0. Also notice that the power or the exponent on x is invisible. When it is invisible, we assume it to be 1. So linear equations are equations in this form, and also the exponent on your variable is 1. Here's an example of a linear equation. 4x plus 2 equals 6. Now let's go in our books to page 120, and we're going to look at numbers 1, 3, 7, and 9. The instructions say identify the linear equations in one variable. Number 1 has x minus 9 equals 13. Well, notice that the exponent on your variable x is invisible, so we assume it's 1. Therefore, this is linear. It follows the form ax plus b equals c. Let's look at number 3. Now we have x squared minus 9 equals 13. This time, the power on our variable is 2. Therefore, this is not linear. All right, number 7. We have the square root of 2, x, plus pi equals 0.3 repeating. Now recall that the form of a linear equation is ax plus b equals c. So even though we have the square root of 2 and the pi, we're going to look only at the variable x. The exponent on x is the 1. Therefore, this is linear. A is represented by the square root of 2, b is represented by pi, and c is 0.3 repeating. And remember that a, b, and c can be any number. And then last one, number 9. Now we have the absolute value of x plus 2 is equal to 5. Now be careful. Even though the power or the exponent on your variable is 1, notice that now we have absolute value bars. In the form ax plus b equals c, there are no absolute values. Therefore, this does not follow the form of a linear equation, and we will say it's not linear. All right, now objective 2. Let's use the addition property of equality to solve equations. So the addition property of equality says the following. The same real number may be added to both sides of an equation without changing the equation solution. This can be expressed symbolically as the following. If a equals b, then a plus c is equal to b plus c. So the addition property is just saying that you can add or subtract the same number on both sides of the equation without changing the solution. Now make sure you're doing it on both sides of the equation, and it must be the same number. Now let's look at some examples. Let's go again to page 120, and we're going to start by looking at number 11. And it says, solve each equation using the addition property of equality. Be sure to check your proposed solutions. And number 11 has x minus 4 equals 19. So our goal here is to solve for x, and we have x minus 4 equals 19. Now logically, we can think of a number that we can subtract 4 from and get 19. But let's try to follow the steps. So we're solving for x. So what I'm going to do is draw a line down my equal sign. And I'm going to say this is the left side of my equation, and this is the right side of my equation. My goal is to isolate the x. So who is hanging out with x? The minus 4. Now in order to move the minus 4, you have to do the opposite. So what is the opposite of subtracting? It should be adding. So I'm going to add 4 on the left side, which means I also have to add 4 on the right side. On the left side, I still have x. The minus 4 and the plus 4, they cancel each other out. And on the right side, 19 plus 4 is 23. So again, I go back over to my left side. X is now isolated and is equal to 23. Now let's check our solution by taking the answer and plugging it back in. 23 minus 4, does that equal 19? Well, 23 minus 4 is 19, so 19 equals 19, and it's true. All right, let's look at number 19 now. So we have 7 plus z equals 11. This time our variable is z. So we're going to solve for z by isolating it. So again, draw the line down your equal sign. This represents the left side, and this will be the right side. In order to isolate the z, we need to move the 7. Now, what kind of 7 is it? Is it positive or is it negative? Because it doesn't have a sign, we assume it's positive. So how do you move a positive 7? Think of positive the same as saying adding 7. Therefore, we're going to subtract 7. And 7 minus 7, that cancels out, right? And now you're left with z. Z equals 11 minus 7, which is 4. And again, you can take the answer and plug it back in, and you'll see it's true. All right, number 23. So we have x plus 1/3 equals 7/3. So we have x plus 1/3 equals 7/3. Again, we're going to draw a line down the equal sign. This will be the left side, and this will be the right side. And our goal is to solve for x. So this time we're adding 1/3, which means we need to subtract 1/3, and subtract 1/3 on the left side and the right side. On the left side, we're left with x equals, well, 7/3 minus 1/3 is 6/3, which is 2. So x equals 2, and again, you can plug it back in, and 2 plus 1/3 is 7/3. All right, number 31. And we have 3.2 plus x equals 7.5. This time we're solving again for x. So let's draw the line down our equal sign. And we have 3.2 on the left side. And in order to move it, we're going to subtract it. So subtract 3.2 on both sides. Subtract 3.2 on both sides. On the left side, we're left with x. And we have x equals, well, 7.5 minus 3.2 is 4.3. And again, you can take the answer and plug it back into the original equation, and you'll see that it's true. So remember, if something is subtracting and you need to move it, just add it. If something is adding or positive and you need to move it, just subtract it. So the opposite of adding is subtraction. And the opposite of subtracting is adding. All right, let's look at a few more examples. Number 45, 52, and 53. So number 45, same instructions, solve for the variable. And now we have 6y plus 3 minus 5y equals 14. And our goal is still to isolate the variable. Now notice that on the left side of our equation, we have two y's. We have a 6y minus a 5y. So the first thing we're going to do is combine our like terms. 6y minus 5y, well, that's just y. Don't forget the plus 3 is there. So now we have y plus 3 equals 14. Now this equation looks the same as the other ones. Y plus 3 equals 14. We need to get y by itself, which means we need to move this plus 3, and how we're going to do it? By subtracting. And we have y equals 11. This time, to check it, make sure you plug it all the way back into the original equation. So where you see a y, put in the 11, and see if the left side equals the right side. All right, number 52. Now we have 20 minus 7s equals 26 minus 8s. Again, let me draw my line down the equal sign. Distinguish between the left side and the right side. Okay, so this equation looks completely different. This time we have a variable on the left side as well as the right side. Our goal is to isolate the variable. So the first thing we need to do is get our variables together. Always move the smaller variable. So this says negative 7s, and this says negative 8s. Who is smaller, negative 7 or negative 8? Negative 8. Therefore, I'm going to move the entire negative 8s. How would I move it? It's subtracting, so let's add. So I'm going to add 8s, add 8s. Notice how I line them up with the like terms. It keeps everything organized. These cancel out. There's my equal sign. On the right side, I still have 26. But on the left side, now I have 20. And then what is negative 7s plus 8s? It is s or 1s. You can either write the 1 or leave it off because it's usually invisible. So we have 20 plus s equals 26. Now we have to isolate s, so we need to move the 20 to the right side. It's a positive 20, so remember, how do you move something that's positive? We'll just subtract it. Subtract on the left side, subtract on the right side. Cancels out on the left side, leaving you with s equals, and then 26 minus 20 is 6. So s equals 6. And again, you can check it by plugging it all the way back in to the original equation. All right, number 53. Now we have 4x plus 2 equals 3 times parentheses x minus 6 plus 8. And again, we come across an equation that looks completely different. But we're still solving for the variable x. We have x on the left side and we have an x on the right side. However, this time, on the right side, we notice that our variable is inside parentheses. If your variable is ever inside your parentheses, you have to take it out, which means you need to eliminate the parentheses. The only way to do that is to distribute. So this 3 on the outside of my parentheses, he must be multiplied in. Every term inside the parentheses must be multiplied by 3. So the left side is left alone. I still have 4x plus 2 equals, this time we're going to take the 3 and multiply it in. So 3 times x, well, that's just 3x. 3 times negative 6 is negative 18. Do not forget the sign. The sign is very important. That says minus 18. And then don't forget to add the 8. So now we have 4x plus 2 equals 3x minus 18 plus 8. So before we continue by getting our x's together, let's just go ahead and put our like terms together. On the right side, negative 18 plus 8, can't we combine these? What is negative 18 plus 8? Well, it is negative 10. So now we have 4x plus 2 equals 3x minus 10. Now our equation looks the same as it did in number 52. So let's go ahead and get our variables together. So I'm going to say, who's smaller between 4x and 3x? It's the 3. So let's move the 3 over. And how do we move them? We're going to subtract. So subtract 3x. Subtract 3x. 4x minus 3x is x. So now we have x plus 2 equals negative 10. Do not forget that minus sign becomes a negative sign. And let's continue. Now we need to move this positive 2. Since he's adding, we're going to subtract and subtract. Cancels out on the left side. So now we have x equals, well, negative 10 minus 2 is negative 12. And of course, you can check your solution by plugging it all the way back in to the original equation. Everywhere you see an x, you will put in the negative 12. And your goal is to see if the left side equals the right side. Okay, so now objective 3. We're going to solve applied problems using formulas. Here's an example. It says there is a relationship between the number of words in a child's vocabulary, V, and the child's age, A, in months for ages between 15 and 50 months, inclusive. This relationship can be modeled by the formula V plus 900 equals 60A. Then it says use the formula to find the number of words in a child's vocabulary at the age of 50 months. Now, the key thing about formulas is to recognize what do the variables stand for. So V represents the number of words in a child's vocabulary. And A represents a child's age given in months. Now we go to the question or what they're looking for, and we're going to pull out the numbers for the variables. So it says use the formula to find the number of words, which means we're looking for V, in a child's vocabulary at the age of 50 months. That's telling us that A equals 50. Now all we're going to do is plug in 50 for A and solve for V. So we have V plus 900 equals 60. And instead of writing A, we're going to say times 50. So we have V plus 900 equals 3,000. 60 times 50, 3,000. Now we get to solve for V. So we need to move the 900. Since it's adding, we are going to subtract. So subtract 900 on the left side and subtract 900 on the right side. On the left side, we're left with V, and we have V equals 2,100 words. Okay, so this will conclude our video for chapter 2.1. Please email me if you have any questions.